My voice is coming back. It takes a while in the morning. Just in the fall. The rest of the time I'm okay. Alright, so you had to do some things last night, a couple of review things, a little factoring, a little grouping, then you went into the radicals. So just to kind of like keep spiraling in a little bit, I just was kind of mixing them up. So are we okay with these? If we're not, tell me. Kind of glance over your work, make any corrections. If you didn't get it though, I'm be glad to do it again. I just don't do everyone because usually if you have no questions, it's kind of just a waste of time. Everybody's okay with this? Okay. Grouping, group the first two, group the second two, they should have a common factor. Factor it out. Factor again. And solve. If you set it equal x squared minus 1 equals 0, that's fine. And solve that way. That's fine. Does this have any domain restrictions? No. Good. Domain or real numbers? Can everybody factor this? Did we do an A times C yesterday? Did we do this one? Yeah. Did we do this one? Okay. I think we did that one. This one, put it over 1. I must have one person that hangs on that thing. So put it under 1, find your common denominator. Shh. Put your common denominator over each term if you struggle. And then reduce it down. This is easy to factor because it's the same as if the 15 t squared was in the front. Just move it around. Just turn it around. You only have factors. You can do it either way you like. If it's easier, do it this way. Move it over. 1 and 1 has a factor of 1. They're both pluses. So there's only one way to put this in. A 3t and a 5t. And solve from there. Okay, so this one had a domain restriction. You can't have a 0 in your denominator. So we're going to remove it. This is what's left. This is what's our allowable domain. Everybody okay with that? I would have switched, this came from the book, I would have switched it around. But whichever way you like to do it is fine. Radical. Oops, I'm sorry.
Do we have to write the domain?
No, I throw that in all the time because pretty soon we'll always be doing domain. I find that Algebra 2 Common Core did a better job with domain. My regular Algebra 2s that came up struggled with the domain. But the Algebra 2 Common Core does a better job. Kind of makes you do domain all the way through, didn't it? Kind of. Not really. You should have. It should have. It's okay. When we all come together, that's right. Domain, I start with right away. By the time we're done with the first month, everybody's little light bulb will go on about domain and say, well, that's all there is to domain. That's not bad. Okay. Isolate your radical first. Remember, always isolate your radical. Square both sides. And then solve. And make sure you check. Again, this domain has a little restriction here. You can't have a negative under the radical sign. So just take out whatever is underneath that and set it greater than or equal to 0. And find your domain. The same thing here. Isolate your radical. Move this over. Be careful when you square this. This is a binomial. Multiply it out. They're descending variables. Get everything to one side. Factor. And make sure you check. Even though this is within the allowable domain, it doesn't work. It's an extraneous rule. solution. Everybody's good with this? We can absolutely do them over, whatever you like to do. Okay, this is a cube root. A cube root has no restrictions. It could use any number. You can put a negative under your cube root. Because it's a negative 8, cube root of negative 8, negative 2 times negative 2 times negative 2. So do the same thing as you do. Isolate your radical first. Now instead of squaring both sides, cube both sides. And solve. Normally these will work because you can have a negative coming out of your radicals. This guy, as soon as it's already isolated, you square both sides, this can't be possible. So the x's, this will tell you right here, not possible. If in fact it said x plus 5 equals x plus 5, that's your all solutions. But when you get down here, that's your no solution. And God bless you.
God bless you.
A good way to check is put that in your calculator. y1, y2, and see if they cross. See if they meet. Did you guys do transformations? Oh, you did them in geometry?
Yeah, we did them last year. We did them all.
Did you do transformations like off your core graphs, off of like radicals and absolute values?
I don't know how you do it. I think something like that. Yeah.
So, did you do this? So say this one starts like this. If I do this, this moves this. 5. Yeah. Okay. We do a lot with transformations without the calculators. You'll be amazed what you can graph without a calculator. Okay. This domain, let's talk about this domain for a minute. This domain is overlapping. This one has a domain restriction, this one has a domain restriction. If I put this on my number line, the 0 goes this way, the 5, God bless you, goes this way. We can't use the 0 because a 0 wouldn't work in this one. It's where they intersect, where they overlap. So our domain restriction is going to be anything 5 and above. Again, isolate your radical. It doesn't matter if you move this one over or the other one over. Either one you want to move over is fine. Square both sides. You get another radical. Combine your like terms. Switch it to the other side. Keep your x. Move that over. The x's go away. This is kind of nice. At this point, if you wanted to, you could take this and divide by 2. That's what they did right here. Could you square both sides? Square both sides. Just don't forget the 2. If you squared this, and you squared this, you're going to get 16 equals 4 times this. Don't forget to square the 2. Comes out the same in the end. And make sure you check. Okay. This is always a little trickier because this we have to multiply out. You have to distribute it out. You're going to get another radical. You're going to collect your terms, -4, add it to the other side. You're going to subtract your x off the other side. That gets rid of your x. And you're going to come down to your radical and isolate that radical. And same thing with this one. You can move either one. It might be easier just to move the radical x, and move that one over. Whichever one you chose to do. Usually I do the harder one, because the easier one, usually works a little bit easier, so if anybody did the harder one, it's usually good. Again, you're going to have to distribute this out. Collect your like terms first. There's your 80, subtract it. There's your x, subtract it. It gets rid of the x. Divide by a -20. Make life a lot smaller here. Square both sides and solve. 135. This one? Yeah. Which one did you move?
I was good until the part I got 4 and then 2.
Okay, you're right here. So you squared both sides. Did you forget to square the 2? So you got 16 is equal to 4 times x minus 5. Okay? So we'll distribute it. We'll add your 20 and divide by 4. This is important, this one. You can do it either way. I'm not a stickler on you have to do it my way. As long as you do it a sound way and there's no guess and check. There is no guess and check at all in pre-calc. At all. Sorry? 136, yeah. Are you okay with this one?
Yeah.
Okay.
This one,
Yes.
can you take out the really like
Move the other one?
yeah.
Sure. So you move this one over, right? Did you put it first or second? Okay, so now your radicals are isolated. You're going to square both sides. So this one pops out. This one, you have to FOIL it out. This is going to give you 100 minus 10 radical x minus 10 radical x will give us minus 20 radical x. Amani, you get that part? I did it. Minus 10 gives you minus 20 radical x. Okay. And then this one, a negative times a negative is a positive. A radical times itself comes out. So we're going to subtract x, that's going to come out. We're going to subtract 100. So we're going to get negative 120. I'm going to divide by negative 20. Guys, I don't want to hear talking. And then square both sides. Okay? This is the tricky part. The FOILing no doubt again. It's not as easy as a monomial. A monomial says raise to the power, multiply your exponents. A binomial says you have to multiply it out. Think of a really simple binomial like this. Excuse me. So this one you would have to do, FOIL it out. So every time you see one, you got to FOIL it out. Okay? Is that the last one? That was it. Any domain restrictions? In other words, is there any value of x that I cannot put in there? No. No domain restrictions. We can put any value of x. Does it mean that it's going to work? No, it could be extraneous, but we can put in any value of x. Choose one. We're going to isolate your absolute value just like you isolated your radical. We're going to check for the negative and the positive roots, and we're going to check all the solutions to make sure they're all working. Now, when you have a basic radical, a basic absolute value, what can x be equal to? Negative 3 and positive 3. You have two paths. You have a negative path, you have a positive path.
Right.
So you take out what's in your radical after you isolate, what's in your absolute value after you isolate it. You leave it the way it is. Then you take out your absolute value and you set it to the negative of whatever is over here. So you have two paths when you do an absolute value. A positive path, a negative path. So we're going to keep those two paths in mind. First thing we do, check, is this isolated? Is it by itself? So we're going to make two paths. A positive path, a negative path. Take it out, set it equal to whatever it was there. And we're going to solve that. We don't change that. questions? Robert, you okay? Pencil? I have some on my desk. Okay. I always keep pencils on my desk, so if you ever need one, just feel free to help yourself. I go to Staples when they have their penny sale for pencils. And so now your negative side says take this out and set it equal to the opposite of whatever was there. To the negative of that. I don't change my absolute value. If you did it the way that you change your absolute value and not the other argument, that is fine. But you have to change all your terms in your absolute value. So I don't change my absolute value. I just change the term on the right. I change the one on the right hand side. Just don't change both. So now solve. So get everything to one side. At the haunted board. And do this in here. Just watch this negative sign. We do a lot of factoring here because we're always finding roots and solutions and everything else. So you're going to factor. Now, you have to check all your solutions. The easiest way to check it is to check the right side first, this side, because an absolute value can never be equal to a negative. So without putting it in this one, put it in here. If I put a 6 in here, a 6 times a negative 4 gives me negative 24 plus 6. My absolute value would be equal to a negative. Can that be possible? No. So in this case, I'm rejecting that. My negative 1 makes this positive. So this becomes a positive 4. This becomes 10. Now try this side. Negative 1 squared is 1 plus 3. What did I do? Oh, that's a positive 1. Sorry, positive 1. Negative 4 times a 1 is negative 4, so this gives me a 2. And a 1 minus 3 gives me a negative 2, so 2 is equal to 2. This one's good. Check the right side first, and then go check the other part. My positive here, this will give me a negative 8. Not going to work. Check the negative 3. That'll give me a 12. That'll give me an 18. 9 plus 9 gives me an 18, and I'm good to go. So I have 2 solutions. It's not always what you think it's going to be. So make sure that you test it. Remember doing it? Yes.
Is there ever a demonstration for
Absolute value, unless there's a fraction inside absolute value, if I do 1 over x absolute value, then I have a fraction of problem. But the absolute value itself, no. I would never, I don't even think we'd ever put a radical inside of it, but because it would always be positive anyway. So the only one you'd probably get is a denominator one. That would be it. Okay. Now the inequalities work a little bit different. Your inequalities, you're going to isolate your absolute value sign always gets isolated no matter what you're doing. A greater than gives you an or statement. So a lot of times you'll see me misspell the greater to say greater. That gives you an or statement. And ors on both go out. So your or statements are going like this. Your less than is going to give you an and statement. Now you have a couple of ways to do these. you can build your and statement. That's the quick one. By dropping it down, or you can still separate it, but join it back at the end. And I don't care which way you do it. So we'll take a look at both of those. Here's an and statement. This has nothing to do with this. This should say, write this in an interval notation. So we're gonna use absolute value to get back to this, but somehow it's got placed in the wrong spot. So we're gonna get back to that later. How would you put your solution set for this in an interval notation? What would my solution look like? Read it left to right. It's coming from where? Negative infinity. Where's it stopping? And then what's it doing? Skipping. Starting at 5 to infinity. Okay. That's a 3. Okay, so 3. Good. Negative 5 and positive 3? I wrote over the 3. Okay, so negative 5, positive 3. Okay. So we're going to write our solutions in interval notation. If you do set notation, if you're more comfortable with that, do the set notation first, then write the interval notation. But we're going to go right to interval. I find interval is easier. This guy is a less than. So this is giving me an and statement. An and statement is this, the in between. Now, what's nice about an and statement is you can build your and statement without having to separate it. We'll do it both ways. Isolate your absolute value first, which it is, right? Drop this down. Bring the less than sign over here and negate whatever this is. If there is no variable there, this is a shortcut. If there's a variable there, then we'll do it the long way. But you can take this and negate it. This builds your and statement right away. So solve it simultaneously. So if you would add 5 to all 3 parts. So you're going to get 3 is less than x is less than 7. Now, on a number line again, when you do this, all I want is your critical value. Don't give me the whole number line. Just give me 3, 7. Would it be opened or closed? Open. And an and statement says in the middle. Now, if you prefer to do this one out the long way, that's fine too. It's isolated. Bring it down to the positive. This is your positive root. Bring it down to the negative. When you take the negative of this, what happens when you divide an inequality by a -1 or a negative number? Flips the sign. So it's going to take this and it's going to go like this. So you see your two signs kind of pointing in together? This is going to set up your and statement. But you have to write the word and in first. So we solve. We add 5. And add 5 again. What happens if you don't put an and there is this. It says, here you are at 3, keep going, all the way up. Here you are at 7, keep going, all the way up. Your and statement says, I only want where they overlap. So if you get this far, that's fine. Drop your endpoints and give me your and statement. That's your solution. If there is a variable on this side, then you're going to have to do this out the long way. If there's no variable, you can take this little shortcut. Good with that? The shortcut way, only anyway. The other way we have to do it the long way, because it has to go out both directions. But you can do that the other way for an answer. Good? like this, 3 to 7. If it helps you, you're going to build your inequality in set notation. You're going to put it on your number line, and then you're going to build your interval notation. Once you get used to doing interval notation, you'll never want to do set notation. It's so much easier. Okay. Questions? Good. Stop me if you have any questions. Okay, this absolute value has a fraction. Does it have a domain restriction? No. The variable is not in the fraction. I'm not in the denominator of your fraction. Is the absolute value isolated by itself? Good. So, an OR statement, great OR, says, give me the 2 ORs on your boat here. I have a positive, I have a negative. Take your thing out of your absolute value, keep it the way it is. Take it out of your absolute value. Take the negative of whatever's there, and when you take the negative of the absolute value, you switch the of the inequality, you switch the sign. So you see your things going in 2 different directions here? They're going in 2 different directions. If you don't like the fraction, get rid of it. There's no don't cross multiply in an inequality. Get rid of this and work it like a regular inequality. Try to keep your variable on the left-hand side. So let's multiply every term by 2. Let's get rid of this denominator. So this becomes 2 minus t. Makes life a little easier to solve. So you're going to subtract 2 from the other side. And because I have to solve for the positive t, I have to divide by a negative 1. And when you divide by a negative, flip the sign. And do the same over here. Multiply every term by a 2. Subtract your 2. Divide by your negative 1. Now, that's your set notation. If you write set notation, this is what your set notation looks like. Put this on your number line. And work it from here. It's much easier to help you get your interval notation. We're closed, and we're pointing that way to the left. We're closed, and we're pointing this way to the right. So your interval notation says, read it left to right. You're coming from negative infinity, stopping at negative 8, and it's a hard bracket because we have an equal sign. If it was no equal sign, we would have a soft bracket. Or 12 to infinity. Because when you're doing an inequality, you multiply or divide by a negative number, you flip the sign, right? So it seems to kind of hold things. If you're using negative, you're going to have to change the sign. Which makes the sign go the same direction as this. See these arrows? These arrows have to go the same direction because you want your OR statements to go like this. So it's going to flip it so that this one goes in this direction. There's no shortcut for the OR. You have to work it out like this. Good? And I think the last thing is just to build an inequality. So we can take your number line, and we can take a graph, and we can actually work backwards to get to your inequality statement. All you have to do is remember this thing right here, or in case of an OR statement, this. The key part is put this on a number line. It makes much more sense when you put it on a number line. So if my solution is from -2 to +2, I'm going to build my number line, -2 to +2. My midpoint is the number in the middle. Sometimes it's obvious, sometimes it's not over the 0. So to find the midpoint, just like we did in geometry, add the 2 endpoints, divide by 2. So in this case, your midpoint is 0. The difference is the difference from the midpoint to either endpoint, because it will be the same. It's probably easier to look towards the positives than it is towards the negatives. Because sometimes what happens is you're not really sitting at the 0. Your midpoint may be here, -1. In this case, you might want to look towards here and give me a 4. Because this one would be a +3. It would be a little harder to see. So whichever one is easier to see, find the difference. In this case, 2. And then all you have to do is say x minus the midpoint. This is an and statement, and they're both closed. So I'm using the less than or equal to, and my difference is 2. And then just clean this up a little bit. X less than or equal to 2. It'll work itself out with a plus or minus in the inside based on where your midpoint is. If your midpoint is a negative, then this is going to turn into a positive. Because doesn't the transformation go the opposite direction when it's inside the absolute value? This is going to kind of make a little bit more sense to you as we go through this. You're going to see that all those transformations that you learned when you're inside the brackets, inside the radicals, inside the parentheses, they go the opposite way. Same thing happens. We're going to be able to see that actually. Okay?